Today we will discuss about the Amazon SQS. So in this video we will discuss SQS intro and uses, SQS benefits, SQS message workflow, queues available in the SQS, and the cost optimization of the SQS. Let's start with this video with the definition of SQS. So what is SQS? SQS is the simple queue service. That means we can send messages from one end and we can consume the messages from the other end. And queue is helping us to store the messages temporarily. And this is managed by the Amazon. So we can create our queue from the Amazon or AWS console. And this queue is a distributed queue. That means when we are creating a queue, AWS will create this queue on a multiple available zones in a single region. Let's discuss the SQS benefits. First is the security. We can achieve the security with the help of these 2 points. One is the IAM control or access policy. So while configuring the queue, we can set up the access policy like who can send the messages to this queue and who can consume the messages from this queue. Second is the server side encryption. That means we can encrypt the message body and that is doing by the SQS only. So for that SQS required the encryption decryption keys. So SQS can use any kind of encryption decryption keys, symmetric or asymmetric keys. We can also pass our custom keys and we can also use the AWS KMS. AWS KMS means AWS Key Management Service that help us to manage the encryption decryption keys. Next is the durability. So SQS store the messages on a multiple server and also SQS offering at least once delivery or first in first out delivery. Next is the availability. Because SQS is the distributed queue or SQS is storing the messages on a multiple server. If any server failed, we have a other server that will help us to respond back to the user. Next is the scalability. So SQS can handle any kind of spikes. So SQS will automatically scale according to the load. And the next is the support buffering. So SQS clients basically handle or support the buffering. Buffering means in one API call, we can receive multiple messages. That means we can use our consumer smartly. We can consume multiple messages using the limited consumer. Next is the reliability. So reliability is dependent on the message visibility time. That means at a time, the message can be consumed by only one consumer. That message will not be available to the other consumer. Now we will discuss why we need SQS or why we need a queuing system. So let's suppose there is one user that wanted to generate a bill and there is a bill generation backend service and that is generating a bill in a required format. One bill generates in a 2 minute. User is making a request to generate a bill and now user is waiting for 2 minutes. Means we are blocking the user to getting the bill. After 2 minutes, user is getting the bill. The problem with this the architecture is the one is we are blocking the user. Second is the we are blocking the backend service thread. At a some time or after some time, this backend service will be not available to accept more user requests. Now, how we can scale this system? We should use the asynchronous system where we can use the SQS. So let's suppose user is making a request and user is making a request to the SQS server. Now SQS server responding back to the user in few milliseconds like your request is accepted. And the meantime, SQS send the request to the bill generation backend service to generate the bill. And now after 2 minutes, we are informing the user your bill is generated. Now in this architecture, first is user is not blocked. Second is this SQS can handle multiple requests at the same time. So if multiple user is using the system at the same time, that load can handled by the SQS only. Next is the SQS components. So there are three major components. One is the producer. So producer is producing the messages or sending the messages to the SQS queue. Second is the consumer. Consumer is consuming the messages from the queue. And both are same kind of system. Like producer and consumer can be EC2, can be Lambda function, or it can be same EC2. It can be a same service. And SQS queue is storing the messages temporarily. We can drive that feature using the SQS message retention period. So there is one property in the SQS that is message retention period. By default, the message retention period is the 4 days, minimum is the 1 minute, and the maximum is the 14 days. That means SQS can store messages till 14 days. Now we will discuss the SQS message workflow. Here we will discuss how message will pass from producer to the consumer. Here producer is sending a message to the SQS and SQS is storing the message. In any queuing system, there are two type of consumer. One is basically the pull based consumer, second is the push based consumer. Pull based consumer means consumer is making a API call or consumer is polling to the queue for the messages. Push based consumer means queues are basically sending message to the consumer. SQS supports only the pull based consumer. That means consumer need to make a API call to poll the messages from the queue. Once message received by the consumer, then the message visibility timeout start for the message. So default message visibility timeout is the 30 second. So we will discuss the message visibility timeout in detail after this discussion. So for now, we can assume message visibility timeout means this message is still in the queue, but not visible to any consumer. That means this message is invisible to all the consumer. What will happen? We have to basically delete the message. Otherwise, this message will be visible to consumer after some time. To delete the message, this consumer need to make a API call to delete the message. After deleting the message, this message will be deleted. Now there is no message available for the consumer. This is the overall workflow for the message passing from the producer to consumer in the SQS. Next is the message visibility timeout. As we discussed, once the message received by the consumer, the message visibility timeout started for the message. Default message visibility timeout is the 30 second, min timeout is the 0 second, and max timeout is the 12 hour. It means this message is still in the queue but not visible to any consumer. That helps us basically the deduplication. At a time, only one consumer can consume the message. If the visibility timeout is completed and the message is still in the queue, what will happen? After the visibility timeout expiry, the message will be visible to all the consumer. Now this message can consume by any consumer. So basically SQS is locking the message for some time period once the message is consumed by one consumer. Now we will discuss the short polling and the long polling. Here in the SQS we are using the pull based consumer. So basically consumer is making a API call or consumer is calling the SQS queue for polling the messages. So short polling is basically a API call, like consumer is making a API call. If the message is available, then consumer will be consume that message. Otherwise queue will send the empty response to the consumer. The second is the long polling. In the long polling, so consumer is opening the connection and let's go the T0 and the maximum polling timeout is the 20 second. One connection can open till 20 second. So consumer open the connection at T0. Now consumer will wait. If any message is available, consumer will basically consume that message and close the connection. If there is no message available till 20 second, means after the long polling timeout, then the consumer will get the empty response. So here consumer open the connection T0, consumer is waiting. After some time, queue having some message. Now consumer will consume the message and close the connection. If the timeout happened after 20 seconds, consumer will receive the empty response. The next is the queue type. In the SQS, we have a two type of queue, standard queue or the FIFO queue. Standard queue is basically best effort ordering. So order of the messages are not same as we sent to the queue. We are sending the message in that order M1, M2, M3, M4 and M5. But consumer is receiving like M3, M4, M1, M2 and M5. So in the standard queue, order is not strictly maintained, but in the FIFO queue, order is strictly maintained. So if we are sending the message from producer M1, M2, M3, M4, M5, so same way in the same order, consumer will receive the messages in the same order. Now let's discuss standard queue in detail. So in the standard queue, so first is the best effort ordering. So we already discussed the order is not a FIFO order. The standard queue will try the best effort ordering. Second is the unlimited throughput. That means basically we can send any number of messages to the standard queue and we can consume any number of messages from the queue. Next is the spot per message and queue delay. What is the delay here? Delay means when producer is sending a message to the queue, that message is not visible to the consumer for some time period. That is the delay time period. Now this delay time period is we can set on queue and also individual message basis. The max time is the maximum time we can set is the 15 minutes and the minimum time it is the 0 second. Next is the at least once delivery. That means in the standard queue, we will receive the message at least once. Once we receive the message, might we will receive the duplicate message. For that, our consumer need to be idempotent. Means our consumer need to be smart to identify for the processed or unprocessed message. Now the next is the FIFO queue. In the FIFO queue, delivery order is the strictly followed. So basically, first out is the delivery order. So if we are sending whatever order we are maintaining while sending, same order we will consume. Next is the higher throughput. In the FIFO queue, by default, FIFO supports 300 TPS, means 300 API calls. But in the batch, because in one batch we can send 10 requests in the batch, so in the batch we can achieve 3000 TPS, 3000 messages per second. Because in the batch we are making only one API call. That's why in the batch we are achieving the 3000 messages per second. Next is the spot per queue delay. So as we discussed in standard queue, because delay ported on queue and individual message also, but in the FIFO queue, we can set delay on only on the queue. Now next is the deduplication is mandatory. What is a deduplication? So as we discussed, like in the FIFO queue need to maintain the order. For the order, FIFO queue also need to understand duplicate messages. FIFO have a two logic to identify the duplicacy. One is the content base, second is the external ID base. Content base means SQS will generate a hash, and on the basis of hash, basically, if the two message body having a same hash, that means both are the same messages. So for calculating the hash, SQS is using the SHA-256 algorithm. Now the next is the external ID. So external ID means from the code we have to pass the deduplication ID. If two messages having a same deduplication ID means both are the same messages. Now if we are using the external ID, then we have to pass the deduplication ID. That in that case, deduplication ID is the mandatory. Now the next is the group ID. So group ID in the FIFO is a mandatory. So with the group ID, we can achieve the high throughput mode. Let's discuss the what is the high throughput mode. So in the high throughput mode, we can achieve unlimited number of group messages. Previously we discussed in the FIFO, we can achieve only 300 TPS. But in the high throughput mode, if we enable the high throughput mode, in the FIFO, we can achieve unlimited number of group messages. What does that mean? The mean basically we can send any number of group messages, but there is one limitation. In the one group, we can achieve 300 TPS. Per group basis, SQS can only handle 300 requests or 300 API per second. Now the next is the spot group deduplication. Once the high throughput mode is enabled, the deduplication will handle only on the group level, not on the queue level. So if there are two messages and having a same content and both are from the different group, then SQS will assume both are basically the different messages. And if the SQS high throughput mode is disabled, then both are the same messages. Now the next is the dead letter queue. So DLQ. So DLQ is normal queue. We can use any queue as a DLQ. Why we use a DLQ? So DLQ is basically to remove the poison pill messages. Poison pill messages means the messages that we cannot consume. So let's suppose there is one consumer that is polling from the SQS and there is one message available in the SQS server. Now I have mentioned here the two terms. One is the maximum received count and second is the attempt count. Maximum received count means consumer will receive this message two times, and attempt count means this message is attempted how many times. So currently attempt count of this message is 0. Now once this message is received by the consumer, the attempt count will be increased from 0 to 1 and the visibility timeout is started for that message. Let's suppose there is some error occurred during processing this message. So what will happen after the visibility timeout expired? This message is visible to all the consumer. Now again this message will be available for the all the consumer. This message will consumed by any consumer. Now the next time the attempt count is 2. Now again there is some error occurred during the processing this message. Now, what will happen after the visibility timeout expiry? This message is available to all the consumer, but here attempt count is matches with the maximum receive count. So that means this message is available for the to moving from this queue to dead letter queue. So this message will move to DL queue. DL queue is a simple queue, is a normal queue. It's like a standard or a FIFO queue. So any queue can be DL queue. DLQ basically help us to show the unprocessed messages. So to remove the poison pill message. The poison pill means the messages that we cannot process. So let's suppose we are trying messages, one message to process multiple time, but due to some issue we are not able to consume or we are not able to process that message. Now we have to remove the message from the queue, otherwise the message will basically keep rotating from queue to consumer to queue. So we have to move from the queue so we can give chance to the other messages. Second is the when to move to the DLQ. So there are two conditions. So when the message is expired means, so as we discussed, every queue is having a retention period. Once the retention period of the message is expired, then means that message will be moved from simple queue to the dead letter queue. Second is the we already discussed, when the attempt count matches with the max receive count. We attempted the message till the max receive count. After that, that message will move from normal queue to the DL queue. The next is the DLQ compatibility. In a standard queue, if we are using a standard queue, only we can use another standard queue as a DLQ, and FIFO queue use only the FIFO DLQ. So FIFO queue will support only the FIFO DLQ. Next is the DLQ must be in a same region. Wherever we are using the queue, in which region, in same region we have to use the DLQ. Now the next is the SQS cost optimization. First we have to understand how SQS is charging. So SQS is charging on the basis of number of API calls. So how many API calls we are making to process or to send or to receive the SMS. If we are sending the SMS means we are making API call. If we are basically receiving the SMS means we are calling the API. If we are deleting the SMS means we are again hitting the delete API. So that means for that API means SQS is charging. So we can optimize. So how we can optimize? First is use long polling. So long polling means reducing the empty responses. So in the short polling is like a API. So we are making a API. If there is no message, so API will respond with the empty response. Now that is chargeable. Now in the long polling, we are opening the connection that same API till 20 seconds. Till 20 seconds we are using same API. The same API we are waiting for 20 seconds. So at least we are reducing the cost 20x or 10x if we are using the long polling. Next is the use batches while sending or deleting the messages. While sending or deleting means we are making a one API call. Sending means sending API call, or deleting means deleting the API, deleting using the delete API. Now if we are using batching means if we are sending 10 messages in one batch means that is one API. That means we are only using one API. So with the help of batch, we can reduce the cost up to 10x, or 10 times we can reduce our cost of the AWS SQS. Third is the use buffered. That means in multiple AWS SQS client using the buffering. Buffering means while receiving, they are buffering or they are receiving the batch of the messages. If we are receiving one message in one receive API call, that means we have to make 10 API calls. But if we are receiving 10 messages in one API call, that means we are reducing our cost 10 times. With these three fundamental, we can reduce our SQS cost. Yeah, thanks for watching this video. So in the next part, we will discuss how to implement the SQS using the code and how to create a queue using the AWS console. Thanks.